The last time I used a small microcontroller at a low voltage was several years ago. If I remember right, I think I programmed it at 3 or 3.3 volts and ran it at 2 volts. I remember it being a pain, so I guess that's why it's been so long. But I was messing around with some Hall sensor joysticks that go in the DualSense controller, and they run off of 1.8 volts. That got me wondering how well the logic translation in the PICkit 5 would work. So far I've only used it at 5 volts and 3.3 volts. So I thought, let me give the tinyAVR 402 a go at low voltage. So this board is hooked up about like the last board. The big difference is there is no voltage regulator on this one. The voltage input is just jumped to the VCC line. I want to be able to adjust the voltage the microcontroller is operating at. Of course, I'll have to be very careful with the voltage going to it. Absolute maximum is listed as 6 volts. And there is no power LED connected. I do want to test and see how it does at very low current operation, and the LED would kind of mess that up. PA2 and PA3 are connected to the breadboard interface, and are set to analog input for the ADC. Kinda what you would have if monitoring a sensor. PA6 and PA7 are also routed to the breadboard. These are connected to the UseArt module, so I can monitor what is going on with the data visualizer. If the data stream port in the PICkit 5 can work at 1.8 volts. I'm going to start with 1.8 volts going to the microcontroller. Now the PICkit 5 has just been plugged up to the USB port. It has not been accessed as of yet from MPLabX. It's just been powered up. And here's a bit of an oddity. I hadn't noticed this before trying the low voltage setup. Can see that the PICkit 5 is supplying 2.2 volts of target voltage. I just thought that is a bit strange. I really would expect it to power up supplying no target voltage. The PICkit 5's target voltage is set to off in the project, so all I have to do is a device read, and that will access the PICkit 5 and set it up. Of course it's disconnected, so it can't read anything. But now that has turned off the PICkit 5's target voltage output. I think I need to get in the habit of connecting the PICkit 5 to the computer and doing a device read before connecting it to the project at hand. So now a real read to see if it can access the microcontroller at 1.8 volts. And it does fine. Sees the chip and the read completes. Now to see if it can program the microcontroller at 1.8 volts. And it fails. With the failure, it gives a message about slowing down the programming speed. Here you can see at 1.8 volts the UPDI maximum speed is 225 kilobits a second. I had already set the project's PICkit 5 communication speed to 200 kilobits a second. I did try lowering it to 100 kilobits. Made no difference. As it turns out, this error message has nothing to do with why the programming failed. I'll up the voltage to 1.83 volts. The reason for just 30 more millivolts will become clear in a bit. And I'll try it again. Now if the message UPDI pin might be configured to other functionality, I think the microcontroller is hung up. So I just disconnect it and cycle the power to reset it. So now I'll try programming it again with a reset microcontroller running at 1.83 volts. And success. It took me a bit to figure out why I could read from the microcontroller at, well, it turns out even under 1.7 volts, but it would fail to program consistently at anything under 1.83 volts. And it turns out this value here in the BOD table is at the heart of the problem. I have the BOD turned off, which is why I can read and operate the microcontroller at below 1.7 volts. But programming is a bit different. When the chip goes into erase, the BOD is forced on for the erase. And it appears the BOD level for this particular microcontroller is about 1.82 volts. That is almost dead on the 1.8 volt typical value, but can see the maximum value could be up to 2 volts. And I would expect the 1.82 volt level is a bit temperature dependent, as sometimes it would work at 1.82 volts and other times it wouldn't. That does create a problem if I want to be able to update a program in a project that is running at 1.8 volts. There would have to be a way to raise the supply voltage to say 2.2 volts to guarantee that the device will program. Maybe that's the reason the PICkit 5 powers up supplying 2.2 volts of target voltage. It knows that's the minimum needed to program the microcontroller. Certainly would have to make some alteration to the power going to the microcontroller to accommodate raising it to 2.2 volts to program. Here in this circuit, everything is good till over 5 volts and doesn't pull but a few milliamps. But that wouldn't always be the case, and provisions to isolate the microcontroller VDD from the rest of the circuit supply would add some complexity. Of course, if the BOD was the cause of the programming failure, if I enable it, then I should have the same problem with reading the chip as well. So I fire up the MCC and enable BOD at the lowest level. Have MCC generate the code. I do double check the configuration settings it generated. BOD is now active and at BOD level 0. I'll have to program the microcontroller with the new configuration, so I'll raise the supply voltage to 2 volts. And then program the new configuration. A device read at 2 volts works just perfectly. I'll set the supply at 1.84 volts, then a device read, and it completes with no errors. I'll do the same thing now at 1.83 volts, and the same result. It did fine. So now down to 1.82 volts. And here I'm guessing a 50-50 chance of success. Well, it looks hung up. It was able to read the device ID and such, read some of the memory. Then I guess the BOD triggered and pulled the microcontroller into reset in the middle of it. I'll try increasing the supply voltage. Well, let me just do a complete reset on the microcontroller. Yeah, MPLabX wasn't expecting that. I may have to restart the program. It may be the PICkit 5 that is hung up. Let me see if I can disconnect from it. Well, no response. Wait, it now says halting. So it's probably not MPLabX that's hung. It's going to be the PICkit 5. So I'll just restart everything to be safe. After restarting everything and turning off the BOD module in the microcontroller, here I set the supply voltage to 1.7 volts and can see it has no problem reading the device. Communication speed is set at 200 kilobits a second and it's doing fine. As you would expect, if the microcontroller is spec'd to work at 1.8 volts, most of them will operate at an even lower voltage, and this one does. Just can't program it at 1.8 volts. I'm also very interested to see if the data streaming port on the PICkit 5 will work at low voltages. It will really simplify things if it does. So here I have the data visualizer open, port set to the PICkit 5 serial port, and a baud set to 38,400, what I have the DVRT runtime set to in the microcontroller. And the microcontroller is running at 1.8 volts. And so I try starting it up, and I get no response. Here are the waveforms for the data streaming port transmit and receive signals. Channel 2 is the transmit line from the microcontroller. Channel 3 is the transmit line from the PICkit 5. And this is the DVRT ping command on channel 3, but look at the voltage levels for the line. For a 1.8 volt supply, I think I would need at least 1.25 volts to count as a high logic level. It's right at 1.2 volts at the start of the data, but at the end, Maybe it's over 1.1 volts at best. That is a problem. So I up the supply voltage to 2 volts and give it another try. And it starts up this time. Here's the ping command at the 2 volt supply level. Minimum high level should be about 1.4 volts, and I think I'm setting right at it. Notice how curvy the high state level is. Maybe not quite like an open drain output, more like a driver with power supply problems. But it sure doesn't look like a well-driven logic line, and the high level is not anywhere near where it should be. Now here's the data being sent to the PICkit 5 on channel 2. Level is right at 0 volts for low and almost 2 volts at high. Just looks like it should. Notice on channel 3 how the PICkit 5's transmit line is dipping during the data burst. That shouldn't be happening. Something is not right with the PICkit 5's transmit line. But it is able to read the data just fine. So I think the data in line on the PICkit 5 is set correct. I'll drop the supply voltage and see if it can still read the data. At 1.8 volts, still seems to be doing fine. I'll take it down to 1.7 volts and see how it does. Still seems to be fine. I don't know if the PICkit 5 tracks the supply voltage or if it just samples it when it programs the microcontroller. Here's the microcontroller's transmit data, this time at a supply of 1.7 volts. Can see the high level is almost 1.7 volts. So even if the PICkit 5 thinks the supply is at 2 volts, the high level is still well above the minimum high level threshold. The PICkit 5's transmit data line is just not acting correct. I think I'll see how it acts when the power is being supplied by the PICkit 5, see if there's any difference. So I'll disconnect the microcontroller from the power supply. That way no chance of loading down the output from the PICkit 5. And I'll select to power the target from the PICkit 5. I've got the target voltage set to 1.9 volts. The voltage this PICkit 5 puts out seems to be a little on the low side. 40 to 50 millivolts low the few times I've measured it. I don't know if I'm overlooking a setting or something, but the only way I get the PICkit 5 to continue to output supply voltage is to program the microcontroller. A read or debug tool refresh only sends power for the operation and then shuts off the power. Sure would be nice if there was a button to turn the supply voltage on and off. Especially the fact that I can't program this microcontroller at the 1.8 volt level. Though 1.85 volts will tell me if the PICkit 5's transmit data line behaves different with the power being supplied by the PICkit 5. Well, it started right up. No errors, no complaining. Sure wouldn't do that with me supplying power to the microcontroller. So here's the PICkit 5 transmit data line with it supplying power. What a difference. Nice clean waveform. Level is up where it should be for the high state. So the transmit line is working properly. I don't think there's anything wrong with it. There is one more thing I want to try. I'll turn off the target power from the PICkit 5 and go back to the target power coming from my bench power supply. I'll just do a device read. That'll end the power output from the PICkit 5. So I'm going to set the microcontroller supply at 1.8 volts, the listed minimum operating voltage. But I'm going to put a 4.7 k ohm resistor from the 1.8 volt supply line to the PICkit 5's data transmit line. Even though the pin doesn't look like an open drain waveform, I'm curious what just a tiny amount of added pull-up current will do to the waveform. Of course, I'll have to set the voltage up to 2 volts to program it. And maybe that will set the target voltage that the PICkit 5 will be looking for. Just a guess, not sure about that. Reload the symbols in the data visualizer, because it wants to. And I'll lower the supply voltage back down to 1.8 volts before I try and start up the data visualizer. and it started right up. So the pull-up resistor had an effect. Data reads just fine, but the data from the microcontroller to the PICkit 5 has been solid at all voltage levels. So this is the waveform with the 4.7k ohm resistor. So if the PICkit 5 thinks the supply is 2 volts, the minimum high level should be about 1.4 volts. The solid horizontal cursor is set at 1.44 volts, and can see the transmit data is just getting over it. Definitely a bit strange. Below 1.4 volts, good fast waveform. Over 1.4 volts, looks like an open drain configuration with quite a bit of capacitance on it. But it is working. I'll probably reduce the resistance down to 2.2k for a bit of extra margin. But something isn't right with the data stream transmit signal when the PICkit 5 is not supplying the power. From this waveform, I would think that the PICkit 5 thinks the target voltage is 1.4 volts. But MPLabX is reporting that the PICkit 5 sees the target voltage at a little over 1.8 volts. So its internal supply for the logic levels should be very close to that. So I'm not sure what the problem is. But a pull-up resistor seems to let it work, so I'll go with that. A little bit of a bump in the road for low voltage programming. At least it will program at just a bit over the minimum operating voltage, which is nice. If you take into account the maximum value for BOD level 0 at 2 volts, probably should use at least 2.1 volts as the minimum programming voltage. I do wish Microchip would add a button to switch the PICkit 5 power output on and off, or maybe at the very least have 2 voltage selections in the power setting menu for it. 1 voltage for programming and a second voltage for the run value. Either of those would make it a lot more useful. As for the data streaming transmit line on the PICkit 5, I don't think mine is defective, as it works fine with the PICkit 5 supplying the power, but there could be a bug in it. Maybe some output driver is not being turned on like it should be. There just seems to be so little information about the data streaming port in the thing. I think Microchip should talk about it more. It's a very nice feature. Maybe had to do a bit of finagling to get it to work at 1.8 volts, but it's still better than having to translate the 1.8 volt logic up to 3.3 volts for my serial to USB converter. So I'm happy with it, as it will get the job done. Thank you for watching.